Yeah, we are looking at the substitutions and transformation for homogeneous first order differential equation. Okay, the equation dy dx, which we make to be equal to g as a function of y, is called homogeneous if this equal to this. What we mean by that is that the given differential equation, you substitute tx for x, ty for y, and then you get back the function back, okay, for all t, okay, not equal to 0. Okay, in this case, that given differential equation can be written as what? In this form. Okay, so, and what that means is that our can be written in this form or in this form. Okay, and what we are saying is that uh, the given differential equation, okay, which is this, is homogeneous if it can be written in this form. Okay, so that's that on this. First order differential equation determine whether the following differential equation is homogeneous or not. And don't forget that in this aspect, the uh, the highest differentiation here is just the first order, is 1. The highest differentiation here is 1. Okay, so the y dx, that's the first order differential equation, okay, of order 1. So determine the following. The first one, if the first one we have the y at the x equal to 4x minus 3y equal to what? Equal to 5y minus 10x. Okay, we want to know whether it's homogeneous first order differential equation or not. Okay, and this one, look at the illustration that your dy dx, okay, is g of x comma y. So the g of x comma y is a given function you are given. So, and if it's homogeneous, it must be expressed in this form. So let's see how we can do that. If we check this, okay, if we want to have y over x now, we have to divide each item, divide the numerator by x, divide the denominator by x. So you have 4 here, you have 3 y over x here, and then you have what? 5 y over x here, and then you have what? 10, this one 10, 10x, that would just be 10, this will be 10, okay? That's your g dy dx, and this will give you 4, okay? And in this case now, your dy dx now, you can see now is what? Is is a function of what? Y over x. Okay, so this is what? This is homogeneous. This is homogeneous. This is homogeneous. And then we can go further here. We can now replace y over x with v. We can substitute for y over x, so which is equal to what? F of v. Okay, anywhere you see y over x, put v there, f of v, and that will be equal to what? 4 minus 3v all over 5v minus 10. Okay, so that's that on that case. The only thing is just that your dy dx is the expression, the function given for dy dx is what we call g of x comma y in this illustration. Okay, then you turn it to this expression. Okay, where your dy dx will be functions of this fraction, and this fraction is what we are substituting for as v. Okay, okay. So this is what we have in this place. Okay, so what we can do in this case is to the ix power there for x is 2. Okay, so how can we get y over x now? I think we should divide the numerator and denominator by what? By x squared. So you have 4 here, then you have what? Y over x over y over x squared. So you have y over x here, and that's equal to 5 y over x squared, y squared over x squared, then minus what? Minus 10. So this is your dy dx. And don't forget that your dy dx, the expression here is what we call the g as a function of what? a function of y. Okay, as a function of x and y. So in this case now, you can see that the y dx now can be written in the form f of what? F of this fraction. Okay, and then you can substitute for that, make y over v as v. Okay, and that will give us 4 minus what? 4 minus v over what? 5v squared minus 3. So this is what? This is homogeneous first order differential equation. This is homogeneous. Then the third one, the y dx is equal to x minus y squared all over y squared minus x squared. Yeah, in this case now, the highest power here is, okay, you can also go for either x or y. The highest power is that you can use x squared to divide through. Let's see. If you do that, this is 1 over x here. And this one will be minus y over what? Okay, we have this over what? Here will be what? Y over what? Y over x or square. Then minus what? Minus 1. Okay. With this now, it's 3. Yeah, we can call this one the given expression as what? G of x comma y. G as a function of x comma y. So then we can now have this g of, let's substitute for x using tx and ty if it will give us back the original function. Okay, so this is because what? Tx minus t squared y squared. Okay, this is your x, this is your y. That's what we are that's what we are substituting for, and this will be what? T squared y squared and the minus t squared x squared. Okay, here, now the t is common, we can take t out, then we have x minus what? Minus that t y squared all over. Here t squared is common, we can take it out, and then we have y squared minus x squared. So this one we cancel, this one we cancel. So this is t over 1, this is 1 over t equal to what? Equal to 1 over t equal to x minus ty squared all over y squared minus x squared. Okay, so that's what we have there. So, and if you check it now, you realize that this is not equal to the given function. So this is not homogeneous. This is not homogeneous. You can solve it the other way around. So this is not homogeneous. Okay, so that's that. I think we have one more. We have one more question, which is question 4. This is what we have here. I want to know, so this will be equal to y over x, okay, into brackets. This lane, you can combine it together, and that will be ln y over what? Over x plus what? Plus 1. Okay, so you have this, and this will be equal to the y dx now will now become f of the fraction, yeah, which you can now substitute for this as what? Substitute for this fraction as b, and that will be equal to v into bracket ln v plus 1. So this is what? Homogeneous. This is homogeneous. This is homogeneous. We can still revisit any of this question. So the next thing we want to do now, I want to see how to solve homogeneous first order homogeneous equation. How to solve that.